Next, let me discuss one by one of types of projectile. So first, we are going to deduce the values of time of flight and trajectory and then range of the projectile for horizontal projection. So this is the first 5-mark question. Now let me consider a ball is thrown at the height of the tower. We does not consider the air resistance and we does not consider the mass of the object. So I am simply throw the object from the height of the tower, h. So the foot of the tower and then the ball reaches the distances, I am going to take it as x. So the projectile motion will occur in two directions. One is horizontal, another one is vertical direction. Students, listen here. I am going to just throw the object with the initial velocity u. That's it. That's my work is over. Hereafter, I don't have any work on the object. Hereafter, the mass of the object force is only influenced by the gravitational force. That should be called as projectile motion. So, the object is thrown with the initial velocity, it will be traveled in the horizontal direction like in the form of x-axis. But once he left out from the point of the building, that is height of the tower, he will be occupied by the another force. That force is called gravitational force. So the gravitational force is acting from the point here itself. So gravitational force is acting on the object. It will be attracted by the downwards direction. But you have given certain initial velocity in the form of x-axis. So how much of direction is, how much of velocity you have given the object, it will be travel in the same direction. So you should consider and keep it in your mind, throughout the motion, the horizontal velocity remains constant. Okay students? Throughout the motion of the object, the velocity remains constant. Which velocity? Horizontal velocity. At every point of the object, the gravitation will be attracting. So before that, I told you in vertical motion there is a changing velocity. There is changing velocity because the height is varying, but the horizontal velocity remains constant. So when the horizontal velocity remains constant means here there is no acceleration in horizontal velocity, in horizontal direction. But in the vertical direction there is a changing velocity and then changing acceleration also. Okay students. Here the ball is moving like this motion. Now I am going to prove you this type of motion is like in the form of parabola. So I am going to compare the projectile motion is just like a parabolic motion. You know very well about the parabolic equation, y is equal to kx square or mx square. So I am going to just compare this equation. First I am going to do that one. Then only I am going to resolve the values of time of flight and then range. Okay sir. First I am going to analyze the motion in horizontal direction. First I am going to analyze in motion in horizontal direction. Horizontal direction. Okay sir. Now I am going to push some object with some initial velocity u in x-axis, that is a horizontal direction. So there is certain displacement in horizontal direction. What is the displacement regarding kinematic equation? Yes sir, we know very well. S is equal to ut plus of at square. Now we are going to find the motion in horizontal direction of displacement. So I am going to fix the suffix value of x. So sx and then ux and then ax. Sir, here the sx represents horizontal displacement from the foot of the tower to hit the projectile hit the ground. So it can be taken as x. So sx can be x. Am I right? Good. And then u of x. What is u of x? It should be a conserved one, that is constant in horizontal velocity, horizontal direction. So ux, it can be taken as ux. And what is the value of acceleration in horizontal direction? Once the velocity constant, acceleration becomes 0. So ax becomes 0. Now you substitute the values in the above equation, you will get x is equal to, that is motion in horizontal direction, x is equal to ux into t plus of 1 by 2 into 0 into t square. 0 into anything 0. So we get x is equal to ux into t. For my simplification, I am going to simplify this equation. I am going to get the time value t can be written as x divided by ux, that is displacement divided by horizontal velocity for the future purpose. Okay students, so now I found the values of horizontal direction displacement. Okay, here one more direction motion is available, that one is vertical motion. So now I am going to find out the motion in vertical direction. Motion in vertical direction. So same formula can be used now. So Sy is equal to Uy of t plus of 1 by 2 Ay t square. Here Sy can be written as just the displacement from the foot of the tower to height of the tower y. So y is equal to, what is the velocity of vertical component? 0. So 0 into anything 0 plus of 1 by 2 ay, vertical acceleration can be written as, it's all due to the acceleration due to gravity. So ay can be taken as g 1 by 2 g t square. Now finally I get the vertical displacement y is equal to 1 by 2 gt square. 1 by 2 gt square. You know the value of time? Yeah, t is equal to x by ux. You just substitute the value. So y is equal to 1 by 2 g into x square divided by u square x. Am I right? Sir, I am going to again simplifying. Y is equal to 1 by 2 g u square x into x square. These terms can be considered as a constant. So you know very well about the equation of parabola. So equation of parabola is y is equal to kx square. I already told you know the motion of projectile is compared to the motion of parabola. So y is equal to kx square is equivalent to the equation of parabola. So you can easily say that the projectile motion is like in the form of parabolic motion. So this equation represents y equal to kx square as the parabolic equation. Previously we've seen the projectile motion is like in the form of parabolic. Now I am going to find the how much time the projectile is in the air medium. That should be called as time of flight. Otherwise, the time of flight is defined by the time taken by the projectile to hit the ground. So once I given the initial velocity, that's my work is over. Afterwards, the projectile will reach the ground at what time? So at the time of t equal to 0, it will be started. At what time it will be reached? This difference between the time is called time of flight. So the time of flight is defined by time taken by the projectile to hit the ground. So the displacement of the particle or the height of the particle in y-axis alone, that is vertical direction alone. So I am going to take it as the displacement formula in the form of vertical direction. So I am going to write it as Sy is equal to displacement in vertical direction because there is a decreasing with respect to time. So Sy is equal to Uy of t plus of 1 by 2 a t square. Am I right? So in a vertical direction, there is no velocity. So I am going to take it as uy equal to 0. And then what is sy? Here sy represents the height of the tower. So y can be taken as h. So I am going to take it as sy is equal to h. And then what is the a value? Here the projectile is fully occupied by the gravitation. So a can be replaced by g, because in every point of the projectile gravitation is attracting with the value of 9.8. So but I am going to substitute these values. So sy can be replaced by h, and h is equal to, so uy of t, so initial vertical velocity becomes 0, and then plus of 1 by 2 gt square. So I am going to take it as t as a capital T, that is the time of flight. So h is equal to 1 by 2 gt square. I need the expression of time of flight. Time taken by the projectile to hit the ground, at what time it will be reached. So I am going to rearrange the equation. T square is equal to 2h divided by g. Otherwise it can be written as the whole root of 2h by g equal to t. Listen, students, listen here. Very important phenomenon is given by the time of flight. Are you listening here? The time of flight is mainly depends upon the height alone. Here there is no initial velocity. We did not consider the initial velocity. So the time of flight is mainly depends upon the height of the object. So independent of initial velocity. That means, sir, if you are supposed to do a different way of approaches. One is, I am going to throw the object like in the form of free fall condition, and then one more is, I am going to throw the initial velocity of horizontal direction in the same time, that is simultaneously I am going to do this. So if you do like this, that means the ball is thrown in a free fall condition, it will be reached in the ground. I am going to do one more thing. Another object is thrown with initial velocity. It will be reached in the same time. At the same time, these two objects will be reached, because these are projected at the same height. So time of flight is mainly depends upon the height of the object. So it is independent of initial velocity. Okay, students, very important phenomenon. Mark it down. Horizontal range. What is horizontal range? Sir, the range is nothing but the distance or displacement. So the horizontal range is defined by the projectile covered by the distance from the foot of the tower to which the point hit the ground. So this is the range of the projectile. Now I am going to find out the x distance, that is horizontal range. Sir, we know very simply manner, sir. Horizontal range is nothing but distance. So we can easily define the velocity equal to displacement by time. Am I right? So now I am going to find the displacement. That's why I indicate to you the distance covered by the projectile from the foot of the tower to which the point hit the ground. So this is a displacement. So now I am going to rearrange this equation. Displacement equal to velocity into time. Am I right? So horizontal range also defined by horizontal velocity into time of flight. Am I right? We know very well the expression of time of flight. So initial velocity, that is horizontal velocity, can be written as u. The time of flight is root of 2h by g. So this is the horizontal range expression. Very important one, students. Mark it down. And particularly, listen here, students. The horizontal range is mainly depends upon initial velocity. That means the range is directly proportional to initial velocity. If you are supposed to increase the initial velocity, the range will be increases. And the range is inversely proportional to square root of the gravitation, and the range is directly proportional to the square root of the height. These are all the important one words. You just keep it in your mind and substitute the problems. I am going to find the resultant velocity. Sir, you just throw the object from the height of the tower, sir. Afterwards, you didn't do any work. It's all due to the acceleration due to gravity. But I need the value of velocity at any point of the projectile motion. Shall we take this here? What amount of velocity is present? Sorry, sir. What amount of velocity present here? So now I am going to find the velocity. So we can easily find the resultant velocity by using two components. One is vertical velocity and then horizontal velocity. Now I am going to take a point here. So the horizontal projection is like in the direction of x-axis. Due to acceleration is attracting in downwards direction here, so it is going downwards. Sir, when the two vectors are traveling in somewhat angle, find out the resultant velocity. Yes, sir, I know very well by using triangulation method and then parallelogram method. So here I am going to use this as x component of velocity Vx, and then this one as Vy, that is vertical component of velocity. So by drawing some resultant vector like here, so this is a resultant velocity R or somewhat velocity V. In this case, I am going to find out this velocity. This amount of velocity is traveling like in the whole motion. You can easily find out that by getting the solution. Okay, first we should find out the Vx value. And then next Vy. We can easily find out the resultant vector value. So what is the Vx value? You just find it out. Sir, we know very well about kinematic equation, sir. So velocity V is equal to u plus of at. Am I right? This is the first kinematic equation. So now I am going to find the motion of horizontal direction of velocity V. So I am going to put it as Vx and Ux and then Ax. So we know very well, sir, when the particle travels in the horizontal velocity, the velocity is conserved, that means constant, and then acceleration is 0. So in this case, Ax becomes 0. So what is the final velocity? Vx equal to ux, that is ux can be taken as u, that is the initial velocity which is given by the projectile. So Vx is equal to u alone. And then what is the vertical velocity? Vy. Again I am going to use the first equation. Vy is equal to uy plus of ayt. Here the vertical velocity becomes 0 because uy equal to 0. And then what is the value of ay? So acceleration in the vertical direction is all due to the gravitation alone. So g. Here Vy is equal to gt. Now we can easily find out the resultant velocity. What is the resultant velocity? By evaluating in the parallelogram law of vectors, the magnitude of parallelogram vectors is resultant vector r is equal to root of a square plus b square. Am I right, students? Okay, you can substitute the values of a and b. Here a and b is Vx and then Vy. So resultant vector V is equal to root of Vx square plus of v square y. By substituting these two values, u square plus of g square t square, the whole root. This is the resultant velocity of the projectile motion. By using this equation, you can easily find out at any point the particle's velocity. Okay, students? Okay, listen here. You know one thing. That is what is the time value? T is equal to root of 2h by g. What is the t square value? T square is equal to 2h by g. By substituting this value in the resultant velocity expression, so v is equal to root of u square plus of g square into 2h by g. By simplifying this equation, subtracting the g value, so we get finally root of u square plus of 2gh. This is the speed of the projectile. Okay, students. By using this above formulas, we can easily find the time of flight, horizontal range, and then velocity of the projectile particle at any point for the horizontal projection. Very important 5-mark question. All the best.